Hello and welcome to another episode of AI Frontiers, where we dive deep into the latest advancements in artificial intelligence through cutting-edge research papers on ArXiv. I'm thrilled to guide you through a detailed analysis of 116 papers uploaded on April 15, 2025, covering 39 categories. Our focus today is on the dominant category, computer science artificial intelligence, as we explore key themes, groundbreaking findings, innovative methodologies, and standout papers shaping the future of this dynamic field. Let's begin with an overview of what computer science artificial intelligence entails, before diving into the research landscape of this specific day. Computer science artificial intelligence, often defined as the study and development of intelligent systems, is a multidisciplinary field aimed at creating machines and software that perform tasks requiring human intelligence. This includes problem-solving, learning from experience, understanding natural language, recognizing patterns, and making decisions. It spans subfields like machine learning, neural networks, robotics, and natural language processing, all focused on simulating or augmenting human cognitive abilities. On April 15, 2025, this category led with 18 submissions among the 116 papers on ArXiv, highlighting its central role in current technological innovation and research priorities. As we move forward, let's look at the dominant research themes emerging from these 116 papers. These themes reflect the pressing challenges and exciting opportunities in AI and beyond. First, there's a strong emphasis on enhancing reasoning and decision-making in AI systems, especially through large language models, or LLMs. Many papers explore how these models tackle complex tasks like hypothesis generation, moral decision-making, and automated theorem proving, aiming to make AI a partner in creative and analytical thinking. Second, knowledge augmentation and retrieval mechanisms, such as retrieval-augmented generation (RAG) and knowledge graphs, are a recurring focus. These efforts aim to improve factual accuracy and contextual relevance in AI outputs, addressing limitations by grounding systems in structured knowledge bases. Third, autonomous systems and embodied AI are prominent, with applications in self-driving vehicles and unmanned aerial delivery systems. Research here examines AI interaction with real-world environments through active learning, sensor integration, and safety mechanisms, bridging theoretical AI with practical deployment. Fourth, energy efficiency and hardware optimization are critical concerns, with studies proposing novel architectures, pruning techniques for neural networks, and custom hardware extensions like those based on RISC-V, ensuring sustainable AI on constrained devices. Finally, explainability and interpretability in AI models are key, with approaches like causal representation learning and fairness evaluations in educational contexts, addressing the need for transparency and trust as AI integrates into critical decision-making. These themes collectively show a field striving for smarter, more reliable, and sustainable AI systems. Now, let's turn to some groundbreaking findings from the April 15, 2025 papers that push AI's boundaries. In formal theorem proving, researchers developed Kimina Prover, a large language model achieving an impressive 80.7% success rate on the Mini-F2F benchmark using a reinforcement learning pipeline. This state-of-the-art result, with high sample efficiency and scalability, suggests AI's potential to assist in formal mathematics. In energy-efficient neural decoding for intracortical brain-machine interfaces, a novel adaptive pruning algorithm for spiking neural networks offers a 10-fold efficiency improvement while maintaining performance. Hardware simulations on neuromorphic processors show sub-microwatt power levels, a game-changer for medical applications. For autonomous driving, a hybrid architecture combining LLMs with model predictive controllers improves decision-making by up to 52.2% in control adaptability and boosts computational efficiency over tenfold using RAG and low-rank adaptation fine-tuning. In wireless communications, integrating reconfigurable intelligent surfaces into a novel framework enhances adaptability under adverse conditions, vital for 6G networks. Lastly, the HypoBench benchmark reveals gaps in LLM hypothesis generation, with only 38.8% recovery of ground truth hypotheses in complex tasks, highlighting areas for improvement in scientific discovery. These findings underscore rapid progress and persistent challenges in AI. Let's explore the methodologies driving these innovations across the 116 papers. Large language models, often paired with reinforcement learning or retrieval augmented generation, are widely used for tasks from natural language understanding to formal reasoning. Techniques like fine-tuning and quantization enable deployment on resource-constrained devices, while integration with knowledge graphs ensures factual accuracy. Deep learning is prevalent in neural decoding, wireless channel estimation, and image processing, often using novel architectures like graph attention networks. Hardware optimization, including pruning neural networks and RISC-V extensions, reduces latency and power consumption for real-time applications in robotics and medical implants. Simulation and benchmarking, using synthetic datasets and real-world standards like Neurobench, ensure reproducible testing. Additionally, explainability and fairness methods, such as causal representation learning and counterfactual analysis, aim to make AI decisions transparent. These approaches blend theoretical innovation with practical implementation, forming a robust toolkit for AI advancement. Next, we'll spotlight seminal papers exemplifying this cutting-edge work. Among the research from April 15, 2025, 3 papers stand out for their innovative contributions. First, Wang et al. 2025 introduce Kimina Prover Preview towards large formal reasoning models with reinforcement learning. This work presents Kimina Prover, an LLM achieving an 80.7% success rate on the Mini-F2F benchmark using Lean 4, setting a new standard in formal theorem proving with high sample efficiency. Second, Rivelli et al. 2025, with adaptively pruned spiking neural networks for energy-efficient intracortical neural decoding, propose a pruning algorithm for spiking neural networks, yielding a 10-fold efficiency gain and sub-microwatt operation on neuromorphic hardware per the Neurobench benchmark, critical for medical applications. Third, Baumann et al. 2025, in enhancing autonomous driving systems with onboard deployed large language models, offer a hybrid architecture, improving control adaptability by 52.2% and efficiency over 10-fold using RAG and fine-tuning, validating onboard deployment for autonomous systems. These papers highlight the diversity and depth of research addressing formal reasoning, medical tech, and autonomous systems with transformative potential. Reflecting on the 116 papers from April 15, 2025, it's evident that computer science artificial intelligence is advancing rapidly. Themes like reasoning, knowledge augmentation, autonomous systems, energy efficiency, and explainability show a field tackling both technical and ethical challenges. Breakthroughs such as the 80.7% theorem proving success rate, 10-fold neural decoding efficiency, and 52.2% adaptability gains in autonomous driving underscore AI's transformative potential across industries. However, challenges persist. Hypobench's 38.8% hypothesis recovery rate signals gaps in scientific discovery, while issues in knowledge-augmented reasoning and optimization highlight needs for robust frameworks. Methodologically, reliance on LLMs, deep learning, and hardware optimizations shows maturity, with innovation in integrating domain-specific knowledge. Looking ahead, interdisciplinary efforts in heritage management, educational fairness, and decentralized governance suggest continued growth. Seminal works by Wang, Rivelli, and Baumann will likely inspire further research, though addressing generalization, robustness, and interpretability remains crucial. In conclusion, this research landscape paints a vibrant picture of AI pushing boundaries while grappling with complex challenges. Thank you for joining me, and stay tuned for our next episode on AI innovation.